Let's talk about the anatomy of a circle now, since I have wasted plenty of time. So, a circle, one of the holiest shapes in mathematics. Found that joke. It has basically two parts that we really honestly care about. You only need to know two parts of a circle to be able to form the equation of that circle. You need to know the center of your circle. You need to know the radius of your circle. Those 2 points of information give you everything. So, having said that, the standard form is as follows. Notice what's happening here. All we're doing is we're saying there's a bunch of x and y values that are related to the center of your circle, HK, by some equation involving the radius. So we are literally just saying you only need to know your center and you only need to know the radius. In every unknown point that relates to the center and the radius in a particular way forms a circle. Now, let's notice something about this. That looks a hell of a lot like doesn't it? It's a lot like that distance formula. Why is that? What's happening here that would make these two equations look similar? Well, in the case of a circle, we're saying let's take a point, HK. I've written them up here as x1, y1. And let's restrict ourselves to only considering all of the points that are our distance away from it. If we do that, then we're going to trace out a circle, right? So exactly what I mean. X1, Y1. Let's go. Distance of one eraser away. That is a new official unit. Let's go another eraser away in a different direction. Let's do it again. Let's do it again. Let's do this a whole bunch until eventually we can't see that I originally wrote x1, y1. But we can't see that there are a bunch of dots that trace out the boundary of a circle. The equation as I wrote it up here, that would be D, right? And every one of those points are the exact same distance away from your center. So by holding this constant, calling it R, and saying we only care about those points R away from x1, y1, then we can trace out a circle. That's all this equation is doing. That's why it looks so similar to our distance equation. Having said that, let's say we start off not knowing the radius, but we know a point that lies on the boundary of our circle, as with this problem. This is the point -1, 2, This is going to be 0.34. And this is going to lie on the circle. This will be a circle. Squint your eyes, tilt your head. That is a circle. It's abstract art, okay?
It's cute.
Put a little bow on it, right? It's like really cute. Better.
I love it.
So we've got this circle, or so I claim it to be. This point is sitting on the boundary of it. We know that this point is -1, 2. And we know that this point is 3, 4. Well, this thing, this distance, it's going to have to be equal to r, isn't it? Because it's going to have to be equal to the radius of our circle. So what's r then? Well, r is going to be the distance formula. R is equal to, let's call this x1, let's call this x2. X2, Y2, X1, Y1. All right. Then what we're going to have is 3 minus -1, that quantity squared, plus 4 minus 2, that quantity squared. This is going to give us the square root of 4 squared plus 2 squared, which is going to be the square root of 20. 4 squared is 16, 2 squared is 4, so it's square root 20. Everybody agree with me so far?
Mm-hmm.
Well, with this now, we know what r is. Square root of 20. And HK, well, that's the center. So that's going to be -1, 2. So going back to our equation, that means the equation for this circle is going to be r squared is equal to x minus h, that quantity squared, plus y minus k, that quantity squared, or square root of 20 squared, 20, is equal to x minus -1, so just +1, squared, plus y minus 2, that quantity squared. That's it. That's all she wrote. Their circle's ugly, too symmetric. Damn perfectionists. All right, comparing work. They start by saying, let's find r. Same place we did, right? We found r using the distance formula. And we said we know R, we know the center. -1, 2. So plugging everything in to our circle formula, we get our answer. It's just asking for the formula, right? Just want to find the standard form for the equation of this particular circle. That's it. That's everything right there. However, if we wanted, we could expand all of this out, couldn't we? We could say, let's expand x plus 1 squared. I'm going to rewrite all of this over here. 20 is equal to x plus 1, the quantity squared, plus y minus 2, the quantity squared. This can be rewritten as x squared plus 2x plus 1 plus y squared minus 4y plus 4. All of this is equal to 20. Agreed? We can drop these parentheses and rewrite this as 20 is equal to x squared plus 2x. I'm going to save this and add it to that 4 in a minute. Plus y squared minus 4y plus 6. 5, my mistake, sorry. I promise I can do work. Moral of the story, everybody makes mistakes. So if you make a mistake, don't feel bad. That is the only way to learn mathematics. You gotta lean into the hard problems. The problems that you're afraid of and are uncomfortable with, or that you mess up, you gotta lean into those problems. That said, don't ever let a problem beat you. If a problem's making you angry, stop what you're doing, take a break for 30 minutes to an hour, come back to it. Go walk your dog, go fish, do whatever you have to take a break from the problem. Now, coming back to our problem, we want to get this into this form now. Just to do it, right? To show how we would work on this. This is the standard form. I always feel bad initializing or shortening, concatenating standard as STD in a math class, because I kind of feel like everybody feels about math, felt like they feel about STDs. Anyhow, so here we're going to subtract 20 from both sides to get x squared plus 2x plus y squared minus 4y minus 15 is equal to 0. Notice this is in that exact form, isn't it? We're saying A is equal to 1. Excuse me. B is equal to 2. My mistake. D is equal to 2. E is equal to -4. f is equal to negative 15. It's the exact same form, isn't it? That said, we're going to need to know how to complete the square. We're going to need to know how to complete the square because one of the things we're going to want to do is be able to sketch circles based off of their general equation. I don't know about you, but it doesn't strike me as immediately obvious what that circle is going to look like. I don't have the first idea. But I do know, divide out a 4 here and here. That might be useful. Divide out a 4 here and a 4 here. And if I subtract 1, I get 36, which is also divisible by 4. So maybe something here might be useful to notice. So that's what they're trying to say here to here. Divide out 4 first and foremost. When you do that, group all of your x's and all of your y's together and move that constant to the other side. From there, you want to complete the square. This 5 is going to be half squared. Does that make sense what I mean? Is everybody following that? So then, since we added 25 over 4 here, to 4 here, we have to add it to the other side. Simplify. And we get that the standard form of our equation is x plus 5 over 2, that quantity squared, plus y minus 2, that quantity squared is equal to 1. So now we can sketch our circle. Because that's easy to see, isn't it? Our center is going to be at negative 5 over 2 and 2 with a radius of 1. So this is one of those times where if you don't remember how to complete the square, it might be useful to go back and check out that algebra review that I have up on Blackboard. So we put our circle, or the equation of our circle, into standard form. Because it's in standard form, it's now easy to go ahead and draw that circle.
So I have a question.
Yes.
Can you go back to the other slide? Why isn't that standard form is different than that standard form, but we started off as the same equation, right? The same numbers?
Mm-hmm.
Does that make sense?
Why this?
So that is so different than the standard form we have on the whiteboard. Are those, did you start off with the same numbers?
Oh, this is for a different problem.
Okay,
That's
okay.
why.
I was like, wait a second.
Yeah, this was for that
Okay,
general equation.
okay.
Also, something I should note, this is how my notes normally move, is I'll give a problem, explain the problem, and then give the solution of the problem in the same general format of, here's the thing, how to do the thing, the solution to the thing. But to answer your question, it's because they are two different problems.
Thank you.
So, just a note on this, in the event that given a general equation, when you put it into standard form, it gives you a negative value. That means it's not a circle. It doesn't give you something that you can plot. Let's kind of make some intuitive sense, right? Because that would imply that your radius has to be imaginary, because real numbers can't be squared and get a negative number, only imaginary numbers can. So if you get a negative number, it's got to be the square of an imaginary number. So your radius is imaginary. What does that mean? It means your circle is somehow turned inside out, and all of the points along the edge are actually at the center. Like it has no physical meaning in an intuitive way. That said, we've already talked a little bit about this idea of points of intersection. Points of intersection, let's say we have two different equations. We want to find out where they're going to intersect. Well, then that means the same y value is going to have to occur, right? So if that's the case, why don't we just set the two equations equal? Since after all, the equations give us y. So what I'm saying, x squared minus 3 y is equal to x minus 1. It's going to look something like this. X minus 1. All right. In the event that these two things are equal, happens at two different places, right? Happens here. X1, Y1, and here. X2, Y2. What we're saying is that when you put in x1, both equations spit out y1. When you put in x2, both equations spit out y2. Agreed? So if that's the case, then to solve for y1 and y2, when they occur, what x values they occur at, why don't we go ahead and set the two equations equal to each other? X squared minus 3 is equal to x minus 1. All we're saying is the y values are the same, yeah? So because the y values are the same, the equations must be the same. Now we're going to solve for x, because when we do, that's going to be answering the question, what x satisfies this condition, right? So subtracting x from both sides and adding 1 to both sides, this is going to be x squared minus x minus 2 is equal to 0. What did I do? Yeah, I just subtracted x and minus 1 from both sides. Subtract the quantity x minus 1. Now, from here, if you don't know how this factors, you're going to have to apply the quadratic formula. Luckily, this does factor. This factors as x minus 2 times x plus 1 is equal to 0. So what this tells us then is that x has to be equal to 2, or x has to be equal to -1, right? Because the only way for that polynomial to be 0 is if one of these two factors are 0. And the only way for one of these two factors to be 0 is if in this case, x is equal to 2, because 2 minus 2 is 0. Or if x is equal to -1, because -1 plus 1 is 0. So automatically we have two of our points, or our two x values. Now we just have to plug those x values back into either equation to find the y's. I'm lazy, so I'm going to use x minus 1. -1 minus 1 is going to be -2. 2 minus 1 is going to be 1. And notice that is in fact what this tells us right here, right? So just to build some intuition about what we're doing, setting equations equal to each other, we're just demanding that the y values associated with them have to be the same. And if that's the case, when we do this and we solve for x, we're saying if these two equations are the same, what do the x values have to be? And then once we have that information, we go back and we can say, if the x value is that, what is the y value? Make sense? So for the sake of time, I'm going to go ahead and jump through this and jump into the idea of a supply curve. Supply curve measures the price given the number of items you have to sell, right? So if the item being sold, let me put it another way. I don't know if y'all remember, but when the PS2 launched, PlayStation intentionally produced too few PlayStation 2s in order to drive the price up artificially. What they were doing is they were saying, if I have very few of my items to supply, then the price goes up. This isn't the best example because of everything else we're going to be looking at in a minute, but that is what the supply curve is looking at, is the relationship between the unit price and the quantity supplied. And the demand curve is how demand and price interacts. So one is comparing the business side of things if you have a whole bunch of stuff. The other is comparing the consumer side of things if you have a whole bunch of people. Make sense? And again, this is the unit price of the product versus, in this case, the quantity of it being demanded. The equilibrium price is what happens when supply and demand are equal, when they're balanced. So this is the same idea, I shouldn't say the same, this is the related idea to fair price. What the market would naturally set the value of a commodity at. So if both the company and the consumer want and are supplying the same amount of a product. Everybody cool with that? All right. So all we're talking about when we start talking about equilibrium price is when those two equations are equal. So we are literally just going to set them equal to each other and solve just like we did in this last problem, right? And again, I'm going to run through this. I'm going to skip over it. I just want to introduce those two definitions really quick. Mathematical models are exactly what they sound like. It is a model that mathematically defines what happens in real life. So, catch. All right, that marker just took a particular path. I swear if you throw that at the back of my head right now, you're not getting pizza.
Are you getting pizza?
No. They don't pay me enough to do that.
They're gonna hear that on the video.
Say what?
They're gonna hear that on the video.
I'm bleeping it out. That's true. Maybe they will. My students want pizza. I'm just saying.
Do they actually watch these
No.
videos?
I don't think they do anyhow. I hope they don't. All right, so the marker took this path, right? The equation that defines this path looks something like this. Yes, I have this memorized actually. Why? So the equation that models this path looks something like this. What it's saying is, in the x direction, you move like this. In the y direction, you move like this. Then, just because of the way we drew this, it should be a negative. This is a mathematical model of tossing that marker. Now, having just said that, I want to make a very particular point here. This is not actually math. This is the way we communicate math, right? This is no more math than either of those are apples, right? Neither of those are really apples. They're just ways of communicating what an apple is, or what we're talking about. The math was what actually happened. The fact that he could catch that marker just now meant he intuitively understands what I'm communicating here. And this is true for all of you. I want to make this point very, very clear. All I will ever be able to teach y'all is how to communicate the math. You already know on an intuitive level what it is I am saying, because of the way math underpins everything. So if ever you are working on something and it feels like it's beating you and that you're bad at math, you're not. What is hard about these classes isn't the math. Again, you understand this on an intuitive level. What's hard is putting it on paper, communicating it. And that is going to be true for everyone, K up through PhD. The number of papers that are redacted ever, that are recalled after being published and that have to be apologized for and, oh, I made a mistake, is outrageous. And it's almost always because of small mistakes in the way we communicate it. So if you get to a problem and it's beating you, Don't feel like that's a sign of you not knowing math. You do intuitively. You're not a bad mathematician. Excuse me. You just don't know how to communicate it yet, and that's perfectly okay. That's what this class is about. The fact that he could catch this means he knows all of the math to get to the moon and back, intuitively, and that's true for everyone. So I just want to make this point. This is what we would refer to as a mathematical model. That said, this communicates the math. This is not the math. It already happened. Makes sense what I mean? Yeah, cool, awesome, dope. So, as an example of another mathematical model, we've got this lovely projection of profits for Dillard's and Kohl's against years. We're going to rewrite years, T, as 1, 2, 3, 4, 5. Just concatenate to the last digit, right? Or the last 2 digits. This is a projection of what they expect to make, right? So the question becomes, how do they get that data? How do they make those projections? Well, they started by looking at their current sales. So that would be from 2001 to 2004. And we said, all right, 2005, based on this, this is what we think we're going to make. And what they actually do is use what's called a least square analysis, a least square regression, and they curve fit to the data and say, let's extend it out one more year just to see what we think. But this would be an example of a mathematical model. So they use least square regression. We say based on our data, this is what we get. My mistake, the data came in for 2001 to 2005, and then they projected out to 2006. Now the question is, part of the question that should be asked here is why this is actually a bad use of mathematics. What's wrong here, do y'all think? It's not really all that obvious, but they're right to say we can model this based on our existing data. They are wrong to say you can predict. It's a guess. It's a guess based on current situations, current circumstances. You can never actually predict. You can only say based on what has happened, this is a reasonable assumption. But think about entering 2000 or 2020, right? I mean, nobody thought the world was going to start on fire with a near nuclear war and then end in a pandemic, right? So if a business going into 2019 had done this, they would have been way off and a lot worse. So it is, I shouldn't say it is wrong, it is erroneous to say this is a prediction. This is just a guess. You can't predict this way. You can only guess. Having said that, there are a bunch of different models that we're going to talk about in this class. We have the linear model, the quadratic model, the trinomial model, or the cubic, the square root model, the absolute value, and the rational model. Commit these to memory as best as you can, because these will give you general forms that are going to show up all throughout the semester. You're going to keep using these general models over and over and over again. Having said all that, welcome to section 1.3. 1.3 is all about slope. Slope is how inclined a line is. The end. And we measure it by saying, how high up do we go to how far over we went? That's it. It's just rise over run, right? Another way, however, to think of this is to say, I'm just going to move over to the right 1 unit. If I do, how far up or down do I go in the y-axis? That's slope. Everybody cool with this? Now, at the beginning of the lecture, I had said that we're going to have this thing called a derivative. It gives you slope. It gives you something that you can think of as the slope of a function at a point. That is a misnomer. It is intuitively correct, but it is not mathematically accurate. And the reason why is because slope only makes sense in the sense of a straight line. So when talking about slope, assume there's something straight line happening here. Make sense what I mean? So the slope is just the incline of some line. The slope-intercept form of a line can be written as mx plus b, where b is your y-intercept. So when x is equal to 0, all that's left over is b, right? So it's where your function, your graph, your equation, excuse me, this equation is going to have to go through the y-axis. Everybody cool with this? Having said all of this, there are a few cases that we need to be aware of. Two in particular. Undefined slope is just a straight line, up and down. And this kind of makes sense, right? Because what we're saying is slope. Let me break some of these formal definitions up. Slope of y is equal to mx plus b. M is equal to change in y over the change in x y2 minus y1 over x2 minus x1. So, first and foremost, what is this triangle thing? This triangle thing is just saying change. That's all it means.
Just change.
Yep, just change. So when we have delta y, that's what this triangle is a delta sign. It just means change. Delta y over delta x is the change in y divided by the change in x. So how far up do you go compared to how far down, how far over you go? In this case, the order does matter well. Keeping the order, I should say, matters. Is everybody cool with that? So if you subtract y2, if you take y2 minus y1, then you have to divide it by x2 minus x1. But if you change the order and you have y1 minus y2, you have to divide it by x1 divided or minus x2. Does that make sense to everybody? And what this is literally doing this number here. X1, Y1. And together we get that n is equal to y2 minus y1, or yeah, y1, over x2 minus x1. In other words, the line between all of this, so it's easy to tell. What we got is the inclination of this line is defined as m. M is how far up you went divided by how far over you got. The intercept is b, and it's going to correspond, the y-intercept is b, and it's going to correspond to the point 0, comma b, right? So y-intercept is when x is equal to 0. Well, when x is equal to 0, all that's going to remain is b. So when we have this thing going on, this is just x is equal to some constant c. Let's take 2 points on this. This is going to be c, comma, y2. This is going to be c, comma, y1. So the slope of this thing, n, is going to be equal to y2 minus y1 divided by c minus c, which is equal to y2 minus y1 over 0. So this slope can't be defined. Because you can't divide by 0, right? So whenever you see x is equal to a constant, undefined slope. However, whenever you see y is equal to a constant, you have a slope of 0. Why is that? Because it's the exact flip of this, right? You have c minus c up top divided by x2 minus x1 in the denominator. Does that make sense? Yeah. So we could sketch a couple examples, but I think kind of understand this for the most part now. So I want to bring everybody's attention to problems like this. Notice here we've got inches, here we've got feet. You do need to convert these. You convert this into feet. Or this into inches. And then you can solve problems like these, right? So this would be 22 inches converted into feet. So approximately what? That is almost 2 feet divided by 24. Or you can convert the 24 feet into inches and divide 22 by 288. Because the height and the length are going to represent delta x and delta y, right? This will be delta y, that'll be delta x. Excuse me. Having said that, we can think of slope as a rate of change. Oh, there's a clock up there. I didn't even notice it. So we can think of slope as a rate of change. Think about when you're driving. If you want to know how far you go relative to some position, so let's say someone starts some distance away from the origin. And they move away with some initial velocity in a straight line away from the origin. Then their distance from the origin capital D would be equal to how far they initially were plus their speed times how long they were running, right? So you can think of it as the question of, I start here, I start moving, how far am I at some time from the moment I started moving? Well, you have to know how far I was in the first place from the wall, right? If that's what we're measuring, the distance from me to the wall, starting here, I'm some initial distance. Now from time equal to 0 to whenever I stop, the distance I want to move is that speed times time. And I started initial distance di away. So my distance when I stop is going to be the distance I traveled plus my initial distance away from the wall. So in that way, this velocity here is the slope, right? And if that initial velocity is the slope, or if that velocity, I should say, is the slope, then that means slope is kind of like a rate of change. Because velocity is just the rate at which I cover distance compared to the changing of time, right? So it's a rate of change. And that's really all slope is telling you, is how your y variable changes with changes in your x variable. Everybody cool with this? Awesome. Having said all of that, I will let y'all go.